So this is question 7 from the 2022 MAT, and it's another one of these questions where there's a lot of introduction. Again, we don't even get to the questions on this first screen, just like we had in question 6. So a data operator is receiving tokens one at a time through an input channel. The data operator will receive a total of n tokens, where n is greater than or equal to 6, and these are numbered 1, 2, 3, 4, all the way up to n. Data operator is required to pass these tokens to the output channel. However, they must do so using a valid sequence. A valid sequence is one where all the odd tokens appear first, followed by the even tokens, or the other way around. Okay, so we've got to go odd, even, or even, odd. Furthermore, all the odd tokens must appear in either increasing or decreasing order. And likewise, all the even tokens must appear in increasing or decreasing order. Okay, so we've got odd, even, or even, odd. We've got high to low or low to high for the odd numbers. So that's one thing, that's two things. And then we've got high to low or low to high for the even numbers. Okay, so that means we're going to have 2 to the 8 options. All valid sequences for n equals 6 are listed below. 8 of them. Wonderful. The data operator has a storage unit that can hold a sequence and can perform the following operations as they receive the tokens one by one. Pass. Input token goes straight to the output channel. Pop. Instead of taking a token from the input, the token from the right end of the storage unit is removed, provided one exists, and sent to the output channel. Okay. Push L. Input token is pushed in at the left end of the storage unit. Push R. Input token is pushed in at the right end of the storage unit. Okay. Oh, good. They've given an example, so at least I've got those descriptors on this sheet. When n is 6, the storage and output channel is shown for the following sequence of operations, which results in the valid output sequence 1, 3, 5, 6, 4, 2. So 1 comes in, pass it straight through because it's the first number we want out. Then the 2 will come in, so we've got to push it into storage. Doesn't matter if we do a push right or a push left because the storage is empty. Then the 3 comes in, so we pass it straight through. The 4 comes in. We've now got a choice of which side do we want to put it on. If you want to push right or push left, we're going to have to pop that later. So we need to, pop comes from the right. So we need to push right because the 4 needs to come out before the 2. Yes. Then the 5 comes in, we pass it. We can pass the 6, then we pop the 4, then we pop the 2. Yeah, that's all fine. For n equals 6, which valid sequences can the data operator achieve? So, well, we know it can do that one, 1, 3, 5, 6, 4, 2. So could it have done it 1, 3, 5, 2, 4, 6? Well, yeah, it must be able to. So we do the same things here. We pass the 1, push the 2, pass the 3, push the 4, but we'd push left rather than push right. Then we'd pass, no, not pass, we'd pass, push left again, then pop, pop, pop. So yeah, that one's going to work fine. So we must be able to do them in the other order. We must be able to do a 4, 2, 4, 6, 1, 3, 5, mustn't we? Because we'd push the 1, pass the 2, push the 3, pass the 4, push the 5, pass the 6, and then pop, 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 provided we pushed them in the right order. And we could say exactly the same for, well, what would be 6, 4, 2, 1, 3, 5. Oh, actually, would we? Would we be able to do that one? So how would this work? That one, the 1 comes in. So we would have to push the 1. So the 1 would go into storage. Then the 2 comes in. We have to push the 2. And we'd have to push right because it's coming out before the 1. Then the 3 comes in, we push left. The 4 comes in, we push right. Yes, it's going to work. 5 comes in, we push left. Then we pass the 6 and then pop, 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 which gives us 6, 4, 2, 1, 3, 5. So that one works. Right, that's good. So, well, we must be able to do the duplicates of these then, mustn't we? I must be able to do a 2, 4, 6 5, 3, 1. Surely. Will I be able to do that? So 1 comes in, save the 1, then we have to save the 2, which would be on the right. Then the 3 comes in, which, oh dear, actually, can we do this? Oh no, I'd pass the 2. I wouldn't save the 2, I'd pass the 2. Yeah, so we save the 1, pass the 2, save the 3 on the other side, pass the 4, save the 5, pass the 6, and then pop, pop, pop. So that one works fine. There's no way we're going to end up with 5 of them. So we're going to have to, it's going to be when we're trying to reverse the order of both of them. That's the one where it's all going to fall down, potentially, I would have thought. What's the one I've missed out then? So 6, 4, 2. Yeah, so it can't be that one again. What were the other sequences here? 1, 3, 5, 2, 4, 6, 1, 3, 5. Let's go back to the previous sheet. I forgot what they all are. So, oh, I haven't done the 5, 3, 1s. That's what I've not done. Yeah, so 5, 3, 1, 2, 4, 6. That'd be fine. Yeah, that'd work out fine. And then, so I must have a 2, 4, 6, 5, 3, 1. That'd be fine. So that's too many. I've done blinking 7 of them here. Have I got to repeat? Have I duplicated some of these numbers? So I've got 3 of them starting with 2, 4, 6. Oh yeah, I've written down 2, 4, 6, 5, 3, 1 twice. Right, so the question is, so those 6 are fine. The question is, can I do 5, 3, 1, 6, 4, 2? So 1 comes in, I'm going to have to save it. 2 comes in, I'm going to have to save it. And I'm going to have to save it to the right because it's going out before the 1. Then the 3 comes in to the left. And the 4 would have to go between the 1 and the 2, which I can't do. So we're not going to be able to do the ones where we reverse the order of both of them. So it's going to be those 6. Great. God, that was a long-winded start to this question. I've only done one part of it. Right, part 2. For n is greater than or equal to 6 and even, how many valid sequences are there? Justify your answer. Oh, we've just done it. I did this before I even started answering the questions. There's 6 of them because it's just odd, even, or even odd, high, low, or low, high for odd, and high, low, low, high for even. So it's still going to be 8. Regardless, right? So the justification for that is we've got 3 binomial choices. 3 binomial choices. So that is independent of n. So it is that we've got odd, even. I'm just writing out what we had before, / even, odd. And then we've got high, well, let's say high to low or low to high for the odd ones, and then the same thing for the even ones. So therefore 2 to the 3, which is 8. For n is greater than or equal to 6 and even, how many valid sequences can be achieved? Again, it's going to be the same. We've got the same issue. So we can never do high to low for both odd and even. Otherwise, all sequences okay. Otherwise, all valid sequences possible, which means we get 6. Okay. Right, so it doesn't feel quite so bad. I spent so much time on the first part because it led to the next 2 parts. Right, 2 more bits then. In the remainder of the question, n is greater than or equal to 9 is a multiple of 3. A 3 valid output sequence is one where among the tokens 1 up to n, all tokens of the form 3k appear together, ascending or descending. Same for 3k plus 1, yeah, and 3k plus 2. Right, so yeah, they're just, this is fine. So we've got the 147 in order, the 963 going high to low, etc., etc. So that's okay. Then, so why are these ones not valid? Let's just look at these. Right, they've not split them up into the right groups on that one. and this one's in the right groups, but we don't have that going in high to low or low to high. We've got 2, 8, 5. Right, for n is greater than or equal to 9, multiple of 3, how many 3 valid sequences of length n are there? Right, okay, so how is this going to work? What are all of our permutations? So we've got high to low for each one of the sequences, and then we've got how many different ways can we arrange them all. So n is greater than or equal to 9, multiple of 3, how many 3 valid sequences of length n are there? Okay, so now we've got 3 sets, whereas before we had 2 sets. So we got 3 sets of numbers, and each one of those can be going high to low. And we've got different ways of orientating them as well, haven't we? Because before we had, it was either odd, then even, then odd. So we had 2 different ways of arranging the sets. Here we've got 3 sets. So 3 sets of numbers can be arranged in 3 factorial ways. So instead of just having odd, even, odd, 2 ways in the previous one, we've now got 6 ways that we can arrange 3 groups. Plus, each set can be high to low or low to high. So we've got 3 binomial options. 3 binomial options. Choices. So therefore, we're going to have 3 factorial times 2 cubed total permutations, which is 6 times 8, which is 48. That's quite a lot. Okay, so that wasn't too bad. Last part, for n is greater than or equal to 9, multiple of 3, given the input sequence of tokens 1 up to n, yep, how many 3 valid sequences can be achieved, right, using a single storage unit and those operations. Right. Right, this is going to be tricky. So let's try and go for the basic. I'm going to have to try out some options, just see what works. So our basic option, 1, 4, 7, 2, 5, 8, 3, 6, 9. Can we actually do this? So we'd pass the 1, we'd save the 2, then we'd have to save the 3 to the left of the 2, then we'd pass the 4, and then we couldn't save the 5 because it has to go between the 2 and the 3. So we can't even do that one where they're all in order. Okay, so let's make a first statement then. I'll try and build up an explanation over here. So we need to pass one set of numbers and save 2 sets of numbers. Then, so if we're saving 2 sets of numbers, we need to do one of them with pop lefts and one of them, not pop lefts, push lefts, and the other one with push rights to make them into 2 sets. So the 2, okay, let's say one saved set must use push left, and the other use push right. Okay, so what is that going to mean if we're doing that? So that means, what does that mean? What does that mean? So when you're doing push, so push right is just doing that. Push left is doing that. And when you output a push right, you reverse order. And when you output a push left, you get the same order. So we must have you output a push left, you get the same order. So order unchanged. And this one means order changed. Okay, so we must have so therefore, coming off of the back of all of this, therefore we've got the first set must be going from low to high because we've passed it straight through. The second set will be the stuff that we've pushed right, because when we're popping it out, it's coming from this end. So the second set must be going from high to low. And the third set must be going from low to high again, because that's the stuff that we pushed left. So we have to have low to high, high to low, low to high. Okay. And what does that mean then? So what are our permutations that we've got for this then? How many different ways can we arrange that? So we've got our A, B, C, with B being backwards in the middle. Then we could have C, B, A, with B backwards in the middle. And then we'd have the same for A and C. So we're going to have 6 options still. We're going to have 6 valid options. So yeah, we've got that. We've got A, C, B, B, C, A, and then B, A, C, C, A, B. So that is 6 valid sequences possible. Okay, that was sneaky stuff at the end. But yeah, you can see how this is working with a push left, push right. Maybe they could have brought us a step closer to that perhaps at the end, but because I didn't really spot it until getting to this point here, what was happening with a push left, push right. As in, it was necessarily, if you're doing a push right, you're flipping the order, and a push left, you're not. So it only really became apparent at this point. But maybe you would have picked that up in the earlier part of the question. You just didn't necessarily need it in these parts of the question to see that that is what was happening. You could just go through a relatively small number of permutations and see what worked and what didn't. So, but it certainly helped at the end. And then we got those 6 valid sequences. So yeah, that was an interesting question, that one. Again, a lot to read. And imagine the people who sat the paper in 2022 doing their computer science would not have been that impressed that they had a couple of essays to read in question 6 and 7 in order to get through the end of this. Very interesting questions, but I'm not sure I would have wanted them in an exam necessarily. But there you go, that wraps up the 2022 paper.